Hello again everyone, welcome back to ptet.chemistry channel. So this is a continuation of a 5-question series on atomic structure. So this one starts from question 16. It's saying that an atom has 8 electrons and they want the electronic configuration in its lowest energy state. So we know about Hund's first rule, that is to do with maximize parallel spin. So we want to fill in with as many parallel spin as possible first before pairing them. Okay, so maximize parallel spin before pairing. So that means this already break the Hund's first rule, where it already pairs up before filling in with more of the parallel spin first. Okay, so A is definitely out, and we know that they are in different boxes because they are in increasing energy. So we do not fill in the orbital of higher energy first, even though when we want to maximize parallel spin, we don't usually do this. Therefore, we'll try and pair them within the same subshell first before filling in the next energy level. So D is out, and the same thing with C. And the only one that can be correct must be B. When you think about 8 electrons, and it's an atom, so the number of protons must be equal to 8 as well. We are looking at oxygen, where it's 1s2, 2s2, 2p4. And you know for the 2p is to be parallel, and then pair them up. Okay? So that's why we see a small drop in first ionization energy on going from nitrogen to oxygen, because these electrons, when paired in the same orbital, okay, we use the term orbital, they will repel slightly more than the unpaired electrons for nitrogen, where you don't have that paired electron. Okay, so fairly straightforward there. Next question, it involve working out atomic or ionic radii. So we have a mixture of atom, and we also have a mixture of ions here. So I'll just say atomic ionic radii, and they all contain the same number of electrons. Another term for it is called isoelectronic. Okay, so when we look at the question from the whole perspective, we have Ar and then potassium and then calcium. I'm just rearranging them so that it's clear. The proton is 18, 19, and 20. And then the electron is just 18, 18, and 18 because they are isoelectronic, right? Okay, so they all have 1s2, 2s2, 2p6, 3s2, 3p6, which is argon configuration. But going from left to right, you can see that there are more protons, okay? There are more protons than the electrons, okay? Because there are more protons in the nucleus. Therefore, we can say nuclear charge increase, same number of electrons. Therefore, your effective nuclear charge will increase, and therefore what happens is the proton will pull the valence electrons closer to the nucleus. Okay, so your size will decrease because you have a stronger net attraction from the nucleus due to an increase in the number of protons, but keeping the same number of electrons. So it's very important to specify both of these, especially in a theory level question. This is how you think for this multiple choice question. Yeah. So the size will decrease. That means calcium 2 plus is the smallest. So calcium 2 plus is the smallest, and argon is the biggest. So that would be C. All right. Based on this thing, where we just outline the number of protons, the number of electrons, we can see it very, very clearly. Moving to the next question. So back in the days, well, at least a couple of years ago, they were still using the old notation. So a few years ago, they changed all of these into the new notation. Even your periodic table now consists just of the numerical number instead of the Roman numeral. So that's the old group 4. Now it's called group 14. It's got 4 valence electrons. That means 4 outermost shell electrons, and these are successive ionization energy, so they could call it successive ionization energy. So the first electron being removed, second being removed, and so on and so on. Because you have 4 outer shell electrons, that means your fifth electron to be removed must be from an inner shell. So that inner shell is closer to the nucleus, and therefore the fifth electron to be removed will require a lot more energy to be removed compared to the first four. So you're going to see a drastic increase in the ionization energy from the fourth to the fifth ionization energy. So you're looking between the fourth and the fifth, which one has the most drastic jump? You see the first one here looks like it's drastic compared to the rest, and then it's to trick people who don't read all the options and just jump to conclusion. They will have put A and they will get it wrong, because even though this is big compared to the rest of the changes, but this is the biggest of all. Look at that. That is around 30,000 difference. This is around 3,000. This is around 4,000 difference. This is around 2,000 difference. This is around 30,000 kilojoule per mole difference. All right. I hope you can see that is the biggest difference there. So to go back to our reasoning, the fifth electron to be removed must be from an inner shell, okay, because you only have 4 outer shell electrons for element in group 14, and therefore require a lot of energy to be removed, okay. So it makes sense that the biggest jump goes from the fourth to the fifth ionization energy. Okay, the next question is about counting the number of electrons and neutrons. We always start by the number of protons because that's nice and easy. 4, here's the identity of your element. Whether you are ions, cation or anion, or atoms, your number of proton does not change because there's the identity of the element itself, alright? Now we're talking about the number of electrons. This is atom because there's no charge. This is atom. This is cation. Your number of electrons is going to be lesser than the proton. That's why you get a plus. You get an anion, a negative charge, because you have more electron than proton. So the number of protons equal to the number of electrons for an atom. That's why there's no overall charge. You get a plus 1 charge because you lose 1 electron. You get a minus 2 charge because you gain 2 electrons. So you have 2 extra electrons than the proton. Overall is 2 minus. You have 1 lesser electron than proton. Overall is plus 1. Okay. Now the number of neutron. The number which is bigger is called the nucleon number. It tells you the number of protons and neutrons in the nucleus. The number at the bottom is called the proton number. It's also called atomic number. So the number on top minus the number, well, the bigger one minus the smaller one is going to tell you the number of neutrons. So 19 minus 9 is 10. 23 minus 11 is 12. 18 minus 8 is 10. Okay. The number of electrons and neutrons equal. So we're looking at D. Okay. So the number of electrons and number of neutrons equal there. All right. So you can tell this next question is extremely popular over the years because it can be quite confusing because you've got ion, and ion, and you're looking at electrons, protons, and neutrons. So we got to work out each and every one of it. If I were you, I always start with proton because, as I mentioned, it's the identity of the element. You see, even it's deuterium, which is an isotope of hydrogen, it is still element is still hydrogen. That's why you see the proton number is the same. So the proton number is going to be 1 because it's 1 and 1. But there's no point writing it there, okay? So there's just 1 deuterium, so it's just proton number 1. Here you have an ion of 3 different atoms, okay? So this is a H with 3 of them. So you got 3 protons because 3 times 1, okay? And each oxygen, you got 1 oxygen. Each oxygen has got 8 proton. So you're going to get 3 times 1 plus 8, that's 11. Here you're going to get 8 times 1 plus 1 proton as well, because deuterium is still 1 proton and you only have 1 deuterium. So there's 9. So there's 8 plus 1 as well, because hydrogen is also 1 proton as well. So it's just 9. Now when you're dealing with electrons, do not care about the isotope. As long as you gotten the number of proton correct, follow the number of protons and think about the charge. You have a minus 1 charge. That means you have 1 extra electron. That's because you gain 1 electrons compared to the number of proton. It will be neutral, no charge, if you have equal number of proton and electrons. Okay. Here you have a plus 1. Okay. That means you have lost an electron. So the total number of protons it's 11, which means the total number of electrons when you have no charge is going to be 11, but you have a charge. So it's minus 1 because you lose 1 electron, that's why it's plus 1 there. This is the confusing bit. You lose 1 electron, that's why you need to take away the electron. Now you have 1 extra proton than electron, that's why you have a plus charge. Okay, here is plus 1 because you have a minus 1 charge. Same deal with that here. It's plus 1 because you have a minus 1 charge. Yeah? The neutron is probably one of the hardest bit here, but look at deuterium. The number of neutrons is going to be unaffected by the charges because the charges does not affect neutron, which has no charge, because it's just 2 minus 1. Nuclear number minus the proton number is just that. Okay, when you look at hydrogen, well, H there, the neutron is going to be 0. Okay, so 1H has no neutron. So however many 1H you have, it's not going to have any neutron. I just look at oxygen then. Okay, I'm just looking at oxygen. It's just 8 neutron. Deuterium, on the other hand, has got 1 neutron. Okay, so for deuterium there is 1 neutron, which is from 2 minus 1, give me 1. And then for oxygen there is 8 neutron because 16 minus 8, and there's only 1 oxygen. Okay, so it's 9. Same deal here is 8 for the oxygen, but 0 for the hydrogen 1 because there's no neutron for hydrogen 1. So 8 plus 0, okay, is 8. Now, what are we looking at? You see there are 2 different conditions here. This is the first condition. This is the second condition. The first condition saying electrons more than proton. Okay, electrons more than proton, yes. Electrons more than proton. Electron lesser than proton. Electron more than proton, yes. Electron more than proton. Okay, so I can cancel out B already. B cannot be. The second condition, more protons than neutrons. More proton than neutron. Okay, same number of proton and neutron, so not true. Protons, this is more proton than neutron, so I think we, but hang on, B is already out, right? So there's no point of me looking at B, so not applicable. It's not available because, you know, you can work it out, but, you know, we already worked out the first condition was not satisfied, so we don't need to check for B. This is number of proton, this is number of neutrons. Again, they are the same, which leave us D must be the answer. As you can see, number of protons equal greater than the number of neutrons. So satisfy both the condition. Alright. Again, this is a multiple choice question. It requires a bit of speed, but also require a bit of precision. I've worked a bit slow in this question to show you step by step, but I'm sure in an exam condition you have to be able to work a bit faster, and instead of working out like what I've done here, you might have to just read the question and think about the situation a bit better and a bit faster than what I've done here. Yeah. So this is the end of this 5-question series tutorial on the topical MCQ on atomic structure. So if you like these tutorial videos, please subscribe to the channel and share them widely with your friends, your group chat, and anyone else you think might find this tutorial useful. So I'll see you in the next video. Thank you for watching.